Our General Mathematics, Tagalog-English discussion. Ang ating most essential learning competencies represent real-life situations using exponential functions. What is exponential function? An exponential function with base b is a function of the form f of x is equal to b raised to x or y is equal to b raised to x, where ang b natin ay dapat greater than 0 and not equal to 1. So, examples of exponential functions, we have y is equal to 1/3 raised to x. As you can see, our b here is 1/3 and it is not equal to 1 and it is greater than 0. Our second example, y is equal to 10 raised to x. Our third example, 4 raised to x. So as you can see in our examples, lahat sila, ang exponent nila ay variables. That is exponential function. Let us have an example. Halimbawa ay meron akong function or exponential function na f of x is equal to 4 raised to x. Evaluate natin ang f of 2, f of negative 2, f of 1/2, and f of pi. So, paano natin i-evaluate ang ating given? So, ang una, f of 2. So, that's equal to, when we are evaluating, we are replacing the variable by the value of the x. So, 4 raised to 2. So, we all know 4 squared is equal to 16. So, f of 2 is equal to 16. How about the next one? F of negative 2. So, that's equal to 4 raised to negative 2. And as you can see, ang ating exponent dito ay negative. So, we are going to apply the rule of law of negative exponent wherein para maging positive siya, ibababa natin siya. So, siya ay magiging 1 over 4 squared. Ayan, positive na yung squared natin. So, this is equal to 1 over 16. So, f of negative 2 is equal to 16. Next, f of 1/2. So, that's equal to 4 raised to 1/2. And 1/2 or fractional exponent 1/2, it is equivalent to square root. So, pwede nating i-change ito. This will become the square root of 4. And square root of 4 is equal to 2. Okay? Last is the f of pi. So, f of pi, we all know that pi is an irrational number. So, hindi natin siya i-continue na solution hanggang in terms of pi lang tayo. So, ang ating magiging sagot dito ay 4 raised to 5. So, ito po yung ating sagot sa ating f of pi. Ito naman ang sagot natin sa f of 1/2. This one is f of negative 2. And this one is your f of 2. Punta naman tayo sa transformation of an exponential functions. So, let b be a positive number not equal to 1. A transformation of an exponential function with base b is a function of the form g of x is equal to a times b raised to x minus c plus d, where a, c, and d are real numbers. So, yung ating exponential function natin sa una, it was already transformed into different form. So, we are going to apply this transformation of exponential function sa ating real-life situation. Many applications involve transformations of exponential functions. Some of the most common application nito ay yung real-life of exponential functions and their transformation. So, ano-ano yung mga yon? The population growth, exponential decay, and compound interest. Punta tayo sa una, exponential models and population growth. Suppose a quantity y doubles every t units of time. If y sub 0 is the initial amount, then the quantity y after t units of time is given by y is equal to y sub 0 times 2 raised to t or small t over the capital T. So as you can see in the formula that I have presented to you, sabi dito, it is double. So as you can see, times 2 siya because of the word double. So kapag ang ating problem says triple, of course, it will be times 3. So ang y sub 0 natin dito ay ang initial amount. So whatever initial value is given in the problem, yun ang ating y sub 0. And then yung ating t, yun naman small, yung capital T natin dito, nagre-represent yun ng time na kung saan, kung kailan siya nadudouble. So, ito ay magiging constant, depende sa problem natin. And then, yung small t natin, that will be the question in the problem. So, let us have an example. So, let t, or small t, is equal to time in days. So at time is equal to 0, there were initially 20 bacteria. Suppose that the bacteria doubles every 100 hours. Give an exponential model for the bacteria as a function of t. So kung mapapansin natin sa ating problem, ang initial number ng bacteria natin ay 20. Ang ating time ay 0. At nagdo-double siya, sabi sa ating problem, the bacteria doubles every 100 hours. So, kailangan kunin natin or i-represent natin ito using exponential model for the bacteria as a function of t. So, kung isosolve natin yung ating example sa problem, wherein yung ating time ay equals to 0, we are going to, initially, ang time natin, kung isusulat natin yan, at time 0, sabi sa problem, merong 20 bacteria. So, the number of bacteria at time 0 is equal to 20. So, sabi sa problem, nagdo-double daw yung ating bacteria every 100 hours. Ibig sabihin, kapag 100 hours na siya, T is equal to 100. Yung number ng bacteria natin will be double. So, that's 20 times 2, which is, that's equivalent to 40. So, that means that after 100 hours, our bacteria is already 40. Okay? And then, kung nagdo-double siya ng every 100 hours, ibig sabihin, in another 100 hours, so that's already 200 hours, ang number ng bacteria natin, so dalawang double na yan. So, 20 times 2 squared. Ibig sabihin ng 2 squared, dalawang beses na nag-double yung ating bacteria. If we are going to solve this one, this is 4 times 20. So that is 80. Ibig sabihin, when time is 200 hours, our bacteria is already 80. And then if we continue that, another 100 hours, so that's 300. So the number of bacteria, so ilang double na ito? Tatlong double na. So 20 times 2 raised to 3. And 2 cubed is 8. 2 times 2 times 2. So that's 8 times 20. That's already 160. So as you go with the pattern, mapapansin ninyo, we can produce already the model that we are looking based on the problem. Sa ating formula, the formula that we have is y is equal to y sub 0 times 2 raised to small t all over capital T. So, base sa problem natin, para makompute natin yung ating number of bacteria, which is our Y. So, our Y here is the number of bacteria. So, that will represent our Y. So, Y is equal to Y sub 0. What is our Y sub 0? Yun yung initial number of bacteria natin, which is equal to 20. Times, since sabi sa problem, nag-double, so times 2. And then raised to T. T here, or yung small t natin, yun yung nagbabago na time. So, it becomes 100, 200, 300, divided by our constant time. So, kailan siya nagdo-double? Every 100 hours. So, that is our denominator, the constant t. Because as you can see, on the problem that we have, if we are going, for example, the time, halimbawa lamang ang time natin ay equal sa 600, ilan na kaya ang bacteria nito? So, if we are going to use the model, y is equal to 20 times 2 raised to, ito yung ating small t, yung nasa taas, 600, divided by 100 hour constant. So, 20 times 2, this is raised to 6. And 2 raised to 6 is 64. And 64 times 20, that's already 1,280. So, ibig sabihin, this model that we have is the model to be able to determine the bacteria as a function of T. Punta naman tayo sa tinatawag nating exponential decay. Exponential function can be used also to model radioactive decay. So, ito yung tinatawag na half-life. The half-life of a radioactive substance is the time it takes for half of the substance to decay. Pag sinabi nating decay, yun yung kung saan yung substance natin ay nabubulok. So, we have the exponential decay formula. The formula is y is equal to y sub 0 times 1/2, because from the word itself, half-life, so it is multiplied by 1/2 raised to t or small t over the capital T or the constant T. So, ganun din po ang ating pag-identify. Ang ating y sub 0 is our initial value or of the substance. And then our capital T is the constant value where the substance becomes half-life or decay. Let us have an example. Suppose that the half-life of a certain radioactive substance is 10 days, and there are 10 grams initially. Determine the amount of substance remaining after 30 days. So, if you are going to analyze the problem, sabi sa problem natin, nag-half-life daw yung ating substance or radioactive substance pagkalipas ng 10 araw. Kung meron tayong initial substance natin, which is y sub 0, is equal to 10 grams of that radioactive substance. So, kung nag-half-life siya in 10 days, ilan na lamang ang matitira sa substance natin after 30 days? That is our problem. So, kung isa-solve natin ang ating halimbawa about the radioactive substance, kung isa-solve natin siya, as you can see in the problem, our y sub 0, according to our problem, that's 10 grams. Ayan. So, sabi sa ating problem, 10 grams daw yung amount ng substance natin kailan? Kapag ang time natin ay 0. So, because that's our initial substance, radioactive substance. And then, base sa problem, kapag daw nag 10 days na, so after 10 days, anong nangyayari sa ating substance? So, yung substance natin ay na-half-life. So, from 10 grams, yung amount of substance natin after 10 days will become 5 grams na lang. So, 10 grams after 10 days, naging 5 grams. And then after 10 days again, so that's T equals 20. Additional 10 days. So ano na ang mangyayari sa amount of substance natin? Ang amount of substance natin, pagkalipas uli ng panibagong 10 days, will be the half of 5 grams, which is 2.5 grams. Okay, and then after that, sabi sa ating problem, determine the amount of substance after 30 days. So this is already 20 days. So ibig sabihin, pagkalipas uli ng 10 araw, that's 30 days already. That is the question in our problem. So, ang amount ng substance na natin, amount of substance is equal to the half of 2.5. At ano ba ang kalahati ng 2.5? That is divided by 2, that's 1.25 grams. So, we answer actually the problem. Ang amount ng substance natin after 30 days is 1.25 grams. Okay? But we can represent this one into an exponential model using the one that I have presented to you kanina. So, pwede nating ilagay ito sa ating pinaka-formula. Y is equal to our initial radioactive substance is 10 times, since this is half-life, we are going to multiply it by 1/2 raised to small t, kung ilang oras siya uli magbabago, divided by kung kailan siya nag-half-life. That's the constant t, which is in our problem, ito ay every 10 days. Okay. So, ito na po ang ating exponential model. Let us proceed to the compound interest. If a principal P, our P here is the initial amount of money. So, if a principal P is invested at an annual rate of R. So, yung ating R dito, that is the annual rate, and usually this is in percent. Compounded annually. Then, the amount after T years is given by the formula A is equal to P times quantity 1 plus R raised to T. So, yung A natin, that is the amount under the compound interest environment. Our P is the principal, our R is the rate of interest, and our T is the number of years. Punta naman tayo sa halimbawa ng may kinalaman sa compound interest. So, Mrs. De La Cruz invested 100,000 pesos in a company that offers 6% interest compounded annually. How much this investment be worth at the end of each year for the next 5 years? So, kung isosolve natin ang ating problem about compound interest, dapat ay malinaw sa atin ang pagkakaiba ng compound interest at simple interest. Pag sinabi nating simple interest, ibig sabihin, kung ano ang kanyang principal, yun lamang ang kanyang lalagyan ng interest at hindi mababago ang principal kada taon. So, anong kaibahan ng simple interest sa compound interest? So, let us see yung kaibahan niya dito sa example na to. Sabi dito, how much this investment be worth at the end of each year for the next 5 years. So, kung mapapansin ninyo sa ating halimbawa, ang ating given, ang ating P dito, P is equal, or the principal is equal to 100,000 pesos. So, ang ating rate of interest, which is represented by small r, this is 6%. So, we change this into decimal. Ang equivalent ng 6% sa decimal ay 0.06, or 6 divided by 100 is 0.06. So, if we are going to analyze our problem, sa unang taon, times 0, ang investment niya ay 100,000. So, ito yung pera sa unang taon ni Mrs. De La Cruz. After 1 year, magkano kaya ang pera ni Mrs. De La Cruz? So if we are going to analyze this one, our time is equal to 1, that's annually, or 1 year. So this is equivalent by the formula 100,000 times, ano ba yung formula natin? A is equal to, sulat muna natin, P times 1 plus R raised to T. This is the formula of compound interest, or the amount of compound interest. So balikan natin. So 100 times 1 plus 0.06 raised to 1. So if we are going to solve this one, 1.06 times 100,000, ang pera niya in the first year is 106,000. On the second year, so ang time natin dito is 2. So, magiging, ang ating principal dito will be our 106. That's the difference of compound interest and the simple interest. Dito sa ating compound interest, kung ano ang naging balance sa unang taon, siya ang magiging principal sa pangalawang taon. So, 106 na, or 106,000 ang magiging principal niya, multiply natin yan sa 1 plus 0.06. So, ang ating magiging susunod na value ay 112,360. So, on the second year, ang pera na niya ay 112,000. How about on the third year? So, ang susunod na balance niya ay hindi na 106. This will become 112,360. So, i-multiply natin yan. I-add na natin itong dalawa kasi the same din naman yan, 1.06. So, ang magiging bagong principal niya on the third year, ito yung magiging pera niya at the end of third year, 119,101.60. Approximately, ganyan na magiging pera niya. How about on the fourth year? Magkano ang pera niya on the fourth year? So, our new principal here is 119,101.6. I-multiply natin yan sa 1.06. So, ang ating magiging bagong principal or yung pera niya at the end of the fourth year is 126,247.70. Okay, so that's the money of Mrs. De La Cruz after 4 years. How about after 5 years? Because the question is for the next 5 years. So, tingnan natin, magkano pera niya after 5 years? Our new principal will be 126,247.7 times 1.06. So, ang pera niya ay approximately 133,822.50. So, ito yung pera niya after 5 years. So, using the idea of compound interest, manually, we were able to determine the amount of money for his or her investment after 5 years. But by using the formula, this one, gagamitan natin siya ng exponential function para mabilis natin masusolve. So, if we are going to put that into model, pwede nating isulat A is equal to P. Our P based on the problem is 100,000. Multiply natin yan 1 plus our R is 6%, which is 0.06 raised to T. So, in our problem, yung T natin ay 5 years. So, this is already the exponential model of the problem. If we want to solve that immediately, if we want to know that's 133,000, ito yung shortcut. So, ilalagay mo lang yung A is equal to 100,000. And then, add mo yung 1 plus 0.06. That's 1.06 raised to 5. And you will arrive also on the same value. That's 133,822.5. So, mabilis lang pag meron kang exponential model. So, ito yung ating exponential model. Let us try now different problems. So, let's have the first problem, number 1. Suppose a culture of 300 bacteria at MJD farm is put into a petri dish and the culture doubles every 10 hours. So, hahanapin natin ang exponential model sa ating situation. So, let us now answer. So, in our problem, according to our problem, ang ating initial number of bacteria, so ang ating initial number of bacteria is 300, and based on our formula or model, it is represented by y sub 0. So, y sub 0 is equal to 300 bacteria. And then, so sabi nagdo-double every 10 hours. So, constant ang time natin, which is 10 hours. Ito yung kung saan nagdo-double ang ating number of bacteria. So, if we are going to put that into model, so y is equal to our y sub 0 is 300. Let us multiply that to 2. Bakit 2? Because of the word doubles. So, times 2 raised to t. Ito yung nagbabagong time divided by the constant t. Our constant t here is 10. So, ito naman ay kung kailan siya nagdo-double. So, according to the problem, every 10 hours. So, 10 yung ating constant time dito. So, this is already the answer of our problem. So, y is equal to 300 times 2 raised to t over 10. Let's try again, second example. A certain radioactive substance decays half of itself every 5 days. Initially, there are 50 grams. Determine the amount of substance left after 30 days and give an exponential model for the amount of remaining substance. So, kung sasagutan natin ang ating example, based on the problem, ang ating substance ay nagdi-decay siya every 5 days. So, ang capital T natin, which is our constant time, at kung kailan siya nagdi-decay, so that's 5 days. And our y sub 0 or our initial substance is equal to 50 grams. So, if we are going to put that into an exponential model, so y is equal to y sub 0. This is the formula times 1/2 raised to small t over capital T. So this is the formula of our half-life. So if we put that or relate that in our problem, so y is equal to y sub 0 is 50 times 1/2. 1/2 because this is half raised to t all over the constant, which is 5. Constant time. So this is now the model or the exponential model of the problem. Now, based on the problem, ilan daw ang substance na matitira after 30 days? So using our model, we're going to replace our small t by 30 days. So this will become y is equal to 50 times 1/2 raised to 30 over 5. And 30 divided by 5, this is equal to 6. So, writing again, y is equal to 50 times 1/2 raised to 6. So, this is equivalent to 50 times 1 over 64. So, 50 divided by 64, or 50 times 1 is 50 divided by 64. Our answer is 0.7812. So, approximately, our substance is 0.78 grams after 30 days. So let's have again another example of exponential function, but this time this is all about compound interest or the environment of compound interest. So Aling Dionisia deposits 10,000 pesos in BDO that pays 3% compound interest annually. Define an exponential model for this equation. How much money will she have after 11 years without withdrawal? So solving for the problem, let us identify first the formula or the model that we are going to be our guide, yung guide natin sa pagsusolve sa compound interest. So A is equal to P. A is the amount and P is the principal. Let us multiply that by 1 plus R or small r. Our small r here is the rate of interest raised to T or our time. So based on the problem, our P is equal to 10,000 pesos. Our rate of interest, our R, is equal to 3%. And this will be changed into decimal. So 3% in decimal, 3 divided by 100, this is equal to 0.03. Okay, so if we are going to put this into model, our model is A is equal to the principal, 10,000. Multiply that by 1 plus the rate of interest, which is 0.03 raised to T. So this is now our model for our problem. Now, according to the problem, how much money will she have after 11 years? So, substituting on our time is equal to 11 years. So, what will be the amount of the money of Aling Dionisia? So, this will become A is equal to 10,000, 1 plus 0.03 raised to 11. Okay. So, what will be the amount of money after 11 years? Okay, so that will be, so computing for this one, this is 10,000, 1.03 raised to 11. So, what is 1.03 raised to 11? So, that's equal to, so A is equal to 10,000 times 1.384233871. It's the value of 1.03 raised to 11. So, the money of Aling Dionisia after 11 years is equivalent to 13,842.34. Okay. So, this is the amount of money of Aling Dionisia after 11 years. We also have what we call the natural exponential function. Ano tong natural exponential function? While an exponential function may have various bases, a frequently used base is the irrational number e, whose value is approximately 2.71828. So alam natin, if you are going to go back to the discussion I made, the base is b. And that base b is raised to a variable x. This time, ang base natin hindi na b. Ang base natin dito ay e. This is an irrational number which is approximately 2.71828 value. So the natural exponential function is the function in the form f of x is equal to e raised to x. As you can see, our base here is e already. So going to the example, our example, the predicted population of a certain city is given by p is equal to 200,000 times e raised to 0.03y. Where yung y natin, this is the number of years after the year 2020. So the question in the problem is, what is the population for the year 2030, or predict the population for the year 2030. Going to our example, so we are going to predict the population for the year 2030. So if we are going to analyze the number of years from 2020 to 2030 is 10 years. So it means that our y in our problem is equal to 10. So going to the model in our problem, p is equal to 200,000 times e raised to 0.03y. So if we replace y by 10, solving for this, 200,000 times e raised to 0.03 times 10. Continuing the process, 200,000. We're going to get the value of our e. Our e is 2.71828 raised to 0.03 times 10. So solving for this, our predicted population is approximately 269,971.70. So this is the predicted population of the city. But since we are talking about population, we're going to round this one. So approximately, our answer is 269,972. This is the population for the year 2030. That's the end of our lesson. Our references are the General Mathematics of DepEd and the General Mathematics Pivot for a Calabarzon.